All right, class. Well, unfortunately, we are not in person, or maybe fortunately for some of you. Yep, here we go. We're going to be looking at lesson 5-1, estimate solutions by inspection. So our objective is you can find the number of solutions of a system of equations by inspecting the equation. So we're going to talk about what a system of equation is. So an expectation is anytime you're taking notes, you should be writing the notes down, okay? I don't have any handouts that I can give you, so you need to be writing these things down. So we're going to talk about what is a system of linear equations. This should actually be a linear equation. Let's zoom in here a little bit. A system of linear equations, meaning it is a straight line. So a system is formed by two or more lines. Formed by two or more lines. Okay, so this could be using a linear equation. So it's formed by two equations. It has to have the same variables. Must have the same variables. Okay, so we're going to look at three different scenarios for system of equations. So the first one is this system here is we have a line here and we have a line here, and they are intersecting. So how many solutions do we have? They are intersecting at one point, so it is one solution. So the characteristics that we would have is the slope is different. Slopes are different. The y-intercepts, they can be the same and they can be different, but the main characteristic is the slopes have to be different. The slopes are different. This next one is we have a line here, and it is actually the same line on top of itself. Two equations that form the exact same line. So the number of solutions that we have is infinitely many. And I had to check. For some reason, I have trouble spelling infinitely. That was spelled wrong. Infinitely. There is a T-E-L-Y, many. Okay, so there's infinitely many solutions. So the characteristics are the slope is the same. Slope is the same. And the y-intercept has to be the same. Y-intercept is the same. Our third scenario is we have two lines here, and they are parallel, meaning they never cross. So the number of solutions that we have are no solution. No solution. And the characteristics that we'll have is the slopes are the same. Slopes are the same, but the y-intercept is different. Y-intercept is different. Okay, so those are our three characteristics, three different types of scenarios. This entire chapter is looking at system of equations, and we were going to have these three different types. Intersecting lines, same line. So intersecting line, same line, or parallel lines. This here is just summarizing what I just discussed. You can pause the video, you can look at the equations a little bit and investigate how they're the same or how they're different, how these equations are affecting that. Eventually, we will be looking at how to graph equations on linear equations on a graph. So let's look at example 2 here. Harrison and Pia each buy X comic books. Harrison also buys an action figure for $15, while Pia buys a different action figure for $12. Could they each spend the same amount of money, Y, and the same number of comic books? Explain. So they actually give us these two equations here. So the first one would be Harrison. So this is Harrison. Son, and the second one is Pia. They buy two different action figures that cost a different amount. They are buying the same number of comic books. So could they ever spend the same amount? No, they couldn't. How could they spend the same amount? They're buying two different values for the action figures, but then they're buying the same number of comic books, same value. So no, they can never spend the same amount. And if you notice, the slopes are the same, y-intercepts are different. So these two lines, if we made a sketch of this, would do something like this. They would never cross, okay? And our third example, Corey and Winnie each bought X pounds of cheddar cheese and Y pounds of tomatoes. Corey spent $12 at the supermarket. Winnie spent $24 at the farmer's market. Could they have bought the same amount by weight of cheddar cheese and tomatoes? Explain. So they've given us our two equations here. Are the slopes the same? We don't know. We need to rewrite this in slope-intercept form. So let's go ahead and isolate y for each equation. So I'm rewriting each equation. This one over here on the left, I'll do in blue. So we'll subtract 6x from both sides. So we have 2y equals negative 6x plus 12. Divide everything by 2. So y equals negative 3x plus 6. Our second equation, we'll subtract 12x from both sides. We're isolating y here. This is what we're trying to do. So we have negative 12x plus 24. Divide everything by 4. Y equals negative 3x plus 24 divided by 4 is 6. Are the two equations the same? Yes, they're equal to each other. They're the same. So we can say, could they have bought the same amount by weight? Yes, they could have. Yes, because the equations are the same. Because equations are the same. Okay? When you're taking notes, there are a lot of word problems. I'm okay if you just summarize the word problems. You don't have to write it all down, but I do want you to write down the example that it is, okay? So this is example 3, and then just summarize the key parts. So maybe you just write down Corey spent $12, Winnie spent $24. Or maybe you just summarize the information over here, okay? That's it for today. If you have any questions, please email me. I'm always available during office hours as well, and we can set up a time. Keep up the great work.